Let's solve question 4.6.24. So question 4.6.24. We got an equation 5 plus 2 times e to the power of t equals to 2 divided by e to the power of 5 times e to the power of t plus 1 plus 5. Okay, what can we see here? We can see that we have 5 on both sides, and this is an equation, which means that we can cancel them out. So 5 and 5 cancels out. Now what are we left with? 2 times e to the power of t equals to 2 divided by this term. Well, let's write this as 2 times 1 over e to the power of 5 times e to the power of t plus 1. Why did we do that? Because now we can see that we have 2 on both sides, and this is still an equation, which means that we can cancel it out. It is a common term on both sides. We cancel it out, so we're left with e to the power of t equals to 1 divided by e to the power of 5 times e to the power of t plus 1. Okay, what do we do next? We have e to the power of t plus 1. Well, e to the power of t plus 1, remember the following power rule, that a to the power of x plus y equals to a to the power of x times a to the power of y. So we have the same base, different powers, and we add them up, which means that if we have e to the power of t plus 1, we can write it as e to the power of t times e to the power of 1. So let's do that. If we write this equation again, we have e to the power of t equals to 1 divided by e to the power 5 times e to the power t times e to the power 1. So we literally substituted this into this term. Okay, now we have e to the power 5 times e to the power 1. We have the same base, different powers. Again, we could use our formula that e to the power 5 times e to the power 1, same base, different powers. It means we add the powers up, so that's equal to e to the power of 6, which means we have now e to the power t equals 1 over e to the power 6 times e to the power t. Let's write it a bit differently, which is 1 over e to the power 6 times 1 over e to the power t. We can do that because 1 times 1 is still equal to 1. So this term over here is exactly the same as this term over here. Why did we write so? Well, we did so because we want to use that power rule of ours where we have a to the power of minus m equals to 1 divided by a to the power of m. So we got 1 over e to the power of 6 equals to e to the power of minus 6, and then 1 over e to the power of t equals to e to the power of minus t. So we could write these terms in these places. Let's see where we get with that. We would have e to the power of t, just a second, let's change colors, e to the power of t equals to e to the power of minus 6 times e to the power of minus t. Now again, we have the same base, e, and we add the different powers. So we would have e to the power t equals to e to the power of minus 6 minus t. Last power rule, we have the same base. We have the same base, we have an equation, and the results have to be equal, which means that the powers have to be equal, such that t has to equal to minus 6 minus t. Now let's take the minus t to the other side. So this term, let's take it to the left, and it will become plus t. So t plus t equals to minus 6, which means that 2t equals to minus 6, which means that t equals to minus 6 divided by 2, and that's just minus 3. And this is the final answer. We are done.